Hi everybody, so in this lecture we will practice on limits and asymptotes. Today 13 March. So we will solve this exercise number 1. So we have a function f defined by f of x, and we designate by c the representative curve of the function f. So the first question is to find the domain of definition of the function f. A second question is to find the limits at plus infinity, minus 6, and then to interpret the results. Question 3 is to show that the line of equation y equals x minus 2 is an oblique asymptote. Question 4 is to find a prime of x and then to set up the table of variation. Question 5 is to write the equation of the tangent to c at a point of abscissa 0. So the first question is to find the domain of definition. So to find the domain of definition, we take the expression in the denominator different from 0, that is x plus 6 different from 0, that is x different from minus 6, and then we can write the interval form of the domain of definition, that is x between minus infinity minus 6 or minus 6 plus infinity. So in question 2, first of all, we will find the limit at plus infinity. So when finding the limit at plus infinity, we take the highest power in the numerator and the highest power in the denominator, which is x squared over x. Then, before replacing x by plus infinity, we simplify the expression x squared over x, which is equals to x, and then now replace x by plus infinity. We get the answer equals to plus infinity. Similarly, we can find the limit at minus infinity, which is equals to minus infinity. To find the limit at minus 6, so we need to calculate two limits, minus 6 minus 6 plus, because of the domain of definition. So the limit at minus 6 minus, we just replace x by minus 6 in the expression of f. So we will get in the numerator plus 9 and in the denominator 0 minus, because we are taking the limit at minus 6 minus. So we will get 0 minus. And then a plus 9 over 0 minus is equals to minus infinity, because plus minus equals to minus. 9 over 0 is infinity. Similarly, we can find the limit at minus 6 plus. The difference between the two cases is that we will have in the denominator 0 plus instead of 0 minus. Why? Because we are taking the limit at minus 6 plus. So plus 9 over 0 plus is equals to plus infinity. And then we can deduce that the line of equation x equals minus 6 is a vertical asymptote. We can deduce this because of the last two steps, because of the limit at x equals minus 6 is equals to infinity. So question number 3 is to find to show that the line of equation y equals x minus 2 is an oblique asymptote. So to prove an oblique asymptote, the first step is to evaluate and simplify the expression f of x minus y. So first of all, replace f of x by its expression y, which is the equation of the straight line, that is x equals minus 2, x minus 2. So replace y by x minus 2. Now take a common denominator between the two expressions. So we will have the following, and then after taking a common denominator, so expand and reduce the numerator expression till so we can get 9. The numerator expression is simplified to 9 over x plus 6. So the simplified expression of f of x minus y is equals to 9 over x plus 6. Now to show that the line of equation y equals x minus 2 is an oblique asymptote, you need to find the limit at plus infinity or minus infinity to the simplified expression of f of x minus y, that is 9 over x plus 6. So limit when x tends to plus infinity or minus infinity, you should do the two cases. but they are similar. So limit x tends to plus infinity or minus infinity to 9 over x plus 6 is equals to, we just replace x by plus infinity because this expression is very simplified. So 9 over plus or minus infinity is equals to 0. And then now you can conclude that the line of equation y equals x minus 2 is an oblique asymptote. Finally, what I want to say is to review these 3 questions and try to solve question 4 and question 5. Find the derivative of f, set up the table of variation, and write the equation of the tangent. In the next video, I will do the solution of part 4 and part 5. So try to do them before the next video. Thank you.